give you a shout, okay?
Okay.
Thank you.
Good afternoon, everybody, or good morning. Maybe some people are in the evening as well. So welcome to my workshop. What I'm going to do for you today is a turner's mallet. So if I go that one, you're going to make a turner's mallet. It's a project that I do on my starter courses. I get my students to make one of these. A really useful tool to have around the workshop. But it's a fairly straightforward project using only a couple of tools, sort of 3 tools. This piece is out of beech. I'm going to be using a piece of cherry. You can use wet or dry wood. They're good fun to do them wet. You get lots of lovely streamers, and they go oval. You can see that one's gone slightly oval, as long as it hasn't got the heart in it or the pith. If you cut the lump so it's got it hasn't got a heart in it, they won't split. They should just go oval. If you do use the heart, like there's one here we did, they do tend to split. So not a major problem, but yeah, it's nice to have something that hasn't got a split in it. But that you can see, because that's got the pith in it, it has split. So that's the project. I know there are a lot of varying abilities out there. Some of you may be have been turning for lots and lots of years. Others are just starting out. So hopefully everybody will pick something up out of this, and yeah, just enjoy. It's I'm just going to have fun, showing you this, showing you my techniques, and how I hold stuff. Big thing for me is safety. With work holding, my crusade is to get people to use chucks properly. We're not going to be using chucks today. It's just going to be between centers. So what I want to do is show you a selection of different centers that are available and what I use and what I prefer. So it's there. So I've got here a lump of wood, but also a selection of different types of tail centers and drive centers. We all get them in some sort of excuse me. Forgot to take that one out of there. So the traditional would be 4-prong drive, which you'd use your mallet for. One purpose or reason for using a mallet. They have to be driven in to the wood. Nothing wrong with that. It's a very secure way of fixing. The more, so that's a 4-prong. 2-prong drive I do use mainly for cross grain. So if I put that between my fingers, is that better? You can see that's the 2-prong drive. This I use for using in cross grain. If I'm doing a cross grain form or a bowl, I'll put this in aligned to the grain, so that it's running parallel to the straws, rather than two of the teeth trying to chop the straws up. The more modern ways of driving things are steb centers. This is a multi-tooth piece or multi-tooth ring with a spring-loaded center, quite a stiff spring. I use these quite a lot. That's a bigger one. I use the 1 7/8 because they're available in a small one, 10mm, I think, 3/8, 7/8, and 1 1/8. I use this one for driving quite large pieces, sort of 150 or 6-8 inch diameter, foot deep, with that to drive. Quite like those. The other method, the method I use when I'm teaching, is a friction drive. Now this is a ring center, or sometimes known as a cup center, and the point is adjustable. So I need a longer Allen key to poke that through. So this is a a robust one made by Robust Tools. And the beauty of this is that the profile of it matches the tailstock. So they are identical, and you'll see why that's important as we go through the project.
Oh, you okay?
Yeah,
Sorry, you all right, Chris?
Sorry.
That's all right, mate. Not a problem. What's Bamber up to? Oh, he's gone. Okay.
I just muted him again there.
Right. Okay. So that's means of driving work. I like these because they're a safe method of driving. When I'm teaching, if a student has a catch or pushes the tool too hard, you can set the pressure with the tailstock so that the piece stops revolving. A really good, I find it really useful when I'm teaching. So that's the drives. Obviously we're talking about spindle work here, so we're not going to be using a faceplate unless you're doing your large hollow forms and stuff. But that's more when you're holding it. This is just driving it to create your shapes. Tail centers. Most lathes, the manufacturers supply them with cone centers, which is that's actually an engineering center. This came with a lathe, and this is one made by Axminster. That's a 90-degree point, so that point is actually describes the 90 degrees. Let's just get that right around. Is that in focus? Yeah. Where these are 60-degree points.
Just a little bit lower with those, please. We're going a little bit out of focus. That's better when we're
good. Yeah.
Yeah. Thank you.
So that's the 90-degree. That's a 60-degree point, and another engineering 60-degree point. My issue with these is that if you think of wood as a big bundle of straws, and so that's this wire brush, we think of that as the end of a piece of wood. With a cone center, it just disappears into the straws, and also has no lateral support. So if you have a catch, a design change, whatever you want to call it, that is just going to skid through those fibers. It's also pushing it, the point is disappearing into the wood rather than pushing it onto the drive. So my favorite tail center is the cup center or ring tail center. That as you push up to it, you can see it just doesn't go anywhere. It stops when those fibers go into that ring. They're actually if you cut that in half down there, you'd see a W shape, or a more than a W shape. So the harder you press, the more it gathers the fibers together, and the harder you push on the tailstock, the more friction it creates and the more drive you get. So these are a very, very safe way of driving wood. And the only time I use a cone center is if I'm doing something with a pre-drilled hole, either a pen or a tool handle or something like that. And I haven't made pens for a good few years, and I don't make tool handles anymore. So you know how often I use a cone center. Not very often. So that's what I'm going to use is this is a robust, obviously robust lathe with the drive center and the tail center, which you can't see in the picture at the moment. Right, let me clear this lot away.
There'll be a lot of this information about the equipment you use on your website, Phil, I take it?
Say again, Pat?
A lot of information about the tools, machinery you're using on your website?
No, not at the moment.
Contact you for details for
this is, yeah. I mean, they're pretty self-explanatory. They're easily available, but you're just trying to make more work for me, aren't you? I know. What was I going to say? Lost my thread there. What did you say, Pat?
It was just basically about the lathe and things that you're using if people wanted information to contact you.
Oh yeah, sure. Yeah, yeah. Yeah. Okay, so using in this project, I'm going to use 3 tools. A roughing gouge, skew, and a parting tool. Now they come in various different shapes, sizes, types. So a standard, let's start with a parting tool. A standard parting tool, this is I've had this for, well, I don't know, it's a Sorby one. I've had it for probably 35 years. It's 1/8 thickness. I really like it for when I'm doing my caddy spoons. I can hold it single-handedly and use it as a diameter finding tool. So if I'm using a pair of outside calipers, I can hold that on there and with one hand create the diameter I want. So that's a favorite of mine. Another style is a diamond parting tool. So the diamond section is the thicker part there. Probably doesn't pick up very well there, but it's thicker in the middle of the tool. The idea is that you don't have to create a gap. It's only going to ride on the biggest diameter or thickest bit. I always do 2 cuts if I'm doing any cutting very deep in there. For cleaning the ends of things, I prefer a these called brain fade.
Fluted parting tool.
Yeah, that's the one. A fluted parting tool. Thanks, Pat. Yeah, fluted parting tool. These I really like because the points scribe, so they're actually chopping the ends of those straws up or chopping the straws up before you peel them off. Whereas with a standard parting tool, all you're doing is just lifting the straws up and bending them over. The downside with these is that because they are high-speed steel, if you've got an ordinary or a standard mild steel tool rest, they can nick the rest. This is I've got a hardened rod on it, so it's not really a problem with these. If you do use them on a mild steel rest, you have to keep filing the rest to get rid of the nicks. Otherwise, when you come to use a skew, it's not going to slide along. But they're really great for what I'll show you a bit later on. So roughing gouges, I've got 3 here. A 3/4. I don't know which manufacturer that is. It's a tool I've had for a long time. You can see it's got my own handle on it. Henry Taylor, and they all have, and then a Sorby, and they all have different flute shapes. Although the small one and the larger one have a similar flute shape. I'm going to use the Henry Taylor. It's just, I love this one for when I'm doing my spoons because I can get into smaller places. But for what we're going to do here, that Henry Taylor one is going to be ample. So that's the tools that I'm going to be using. So that one, and then a skew. There are lots of different types of skews, oval, round, rolled edge, whatever, people have their own preferences. When I'm teaching, I just use 1 1/4 or 1 1/8 rolled edge skew, so that the edges, the corners aren't really sharp, and it works nicely on the tool rest. So, does anybody have any questions at that stage?
So far, Phil, just the threads on the end of your drive center, if you would just explain why there's threads on the end of it, please.
Okay. These, because they're American, that one won't come off. They are a 3/4 10 center, 3/4 10 thread, sorry. And there's various things that you can put on. I might use this if I was driving, remounting a.
Change your camera, please.
Sorry, yeah, remounting a say a hollow form or something on there. They've got a 3/4 10 nut in the back. These are from the States. They're from a company called Rubber Chucky, but I've got some nuts that I've got sourced here that I could make my own up. I just haven't got around to doing them yet. These will fit on head or tail stock, and they're really useful. Some one-ways come with aluminium cones, so you can either invert it or have it as an outside cone. So that's what the thread's for. Next question.
That's it, Phil. You're good to go so far. Everything is clear and concise. Crack
Okay.
on.
All right. So the what I'm going to use is a chunk of cherry. This is, I very rarely buy dimension timber. Most of the wood I get is green, and so I just cut it up with an electric chainsaw or chainsaw. Electric chainsaw in the workshop, petrol outside. So various different ways of finding centers. You can use a center finder, or just trouble with irregular wood like this. I've got to go around there 4 times to try and find the center. Whereas with a bit of experience, you can just sort of eyeball it. So that's that end. I just popped that up between centers earlier and got it pretty close. What I do is mark the center. My favorite tool is this little engineering punch, which just with some pressure creates a little divot in there. So it's a spring-loaded punch. You got to put a fair bit of pressure on it to make it work. That's a favorite, but you could also just use a brad awl, just to make a divot in the end there. Pop that back over there. You can get these from any engineering stores, or online now, I suppose, is the favorite place to get them. They are adjustable. You can adjust which one, that bit, to get so you haven't got to press quite as hard. So I actually got a sheet of a thin tin and put a series of marks in it. So I've got a base point and then varying different ones coming out in a line that match up to the diameters of the jaws that I want. The different jaws I've got, so I can just set the calipers to have the one leg in the base point, and then when it drops into the one I want, I know I've got exactly the right setting on my dividers. And that was how I did that. Just a little, throw that one in. The little divots are great for just locating the points. So I can actually feel that going in there. So I can wobble it into that there. So with a little bit less pressure on the tailstock, that's still captured between those points, and spinning freely. And then with a bit more pressure on the tailstock, that now is driven. So I know when I set this up like this, I have the 2 points, 2 of the points horizontal. So when I set the tool rest up, I know that that's going to be, should miss, but it's just touching there. So I can just back that off a little bit. Drop the tool rest down a little bit. When you're using the roughing tool or spindle roughing gouge, make sure you're not going to fall off the end of the tool rest. This tool rest is just long enough to do this, but I'm going to work from this direction. Well, I'll show you two methods actually of roughing down. So that's all clear. Turn the volume down or the speed down. Wind it up. yeah, this is a variable speed lathe. A lot of people ask what speed you run at. Once I've got this is probably 600 RPM at the moment, something like that. Now, I'd normally be wearing a visor, but with the camera mounted here, my head touches it, or the face mask touches it. So that's why I'm going to wear one now, and also for talking, but mainly because I'll do that, and that will be really annoying. So with the roughing gouge, go to tailstock. So you can see I'm just touching there and then lifting into the cut. So I can either peel it down that way, and you can see that was slowing down, so I put a bit more pressure on the tailstock. So this, you can use that method, or do the reversing cut. Now, all the time I'm doing this, I'm watching the profile over here so I can see how much is coming off. I'm going to move the tool rest in, so I'm not having to reach quite as far over. You can increase the speed a bit more now. So you can see where that slowed down then. When I'm teaching, it's really useful because you know that the student is cutting too hard if you've got to keep tightening the tailstock up. So it's a good aid when you're teaching, and it teaches them more about tool control and how the tool approaches the wood. Now, I'm just checking whether that's round. I'm having my thumb trailing, not pushing my finger into it. So it's a safe way of just checking without having to switch the lathe off and on again. I can also feel that I've got that round. A little something I show my students is when you move the tool rest in, you need to lift it up again. Let's go to this way. So if I push that tool rest in now, you'll see that the tool drops down. So it's changing the bevel angle there. If you've got the angle at the same, you develop muscle memory. And when you go back in, if you haven't moved the tool rest up, it cuts differently. So lift the tool rest up a little bit, and then you're back to where you were before. Okay, so that's round, coffee cup full of shavings. Okay, now I'm going to use the fluted parting tool just to clean the ends up and give us a little bit of space so that as I come around with the skew, I don't cut into the tailstock. So what's going to be best here, probably overhead. Let's just move that camera around so you can see a bit better there. How's that? Yep, it's good.
That's good, Phil.
So with this, I need to have the tool rest a little bit higher because I'm going to prescribe an arcing cut. So the tool is going to be down here and then go that arc like that. I'm not going to try and push it straight in because I want to peel these fibers. So it's going to start with the handle really low and then come over and just peel those down. This isn't terribly square, So bit of pressure into the rest. Because I'm arcing the cut, you're getting nice shavings coming off. When I'm teaching, I usually get my students to do 3 widths of the tool here. Just allows a little bit of space, a little bit of leeway. And that's cut that nice and cleanly. Very little tear out in there. If I was going to use an ordinary chisel type parting tool, it would be a lot more furry there. Okay, so I move up to the other end. Move the camera around. Sorry if I'm waving that around at you. Do the same the other end. Usually down to about 3/4 of an inch diameter there. Okay, so I'm just going to move that back there again. How's that? Yep, good. So now I'm going to mark this out, what's going to be the head and what's going to be the handle. So this piece of wood was obviously a bit longer when I made this one. So what I'm going to do is just make the head a bit shorter. So it's about 2/5, 3/5 the proportion between the head and the handle. So if I mark there, and then I'm going to use the skew to mark out where the head's going to be. Now this has got a slight radius on it. You can see there that the points, the long and short point, are slightly drawn back, just a tiny radius on there. Just makes it a bit easier for, or reduces the chance of getting a catch. I say reduces, it doesn't stop you getting a catch, but it just reduces it, because when you're doing a planing cut, those points are a little bit further away from the work. So I'm just going to do, I can see that mark, just put a V cut there, and then come in here. I'm not a great exponent of a skew, but it's a good tool to teach people. If students can understand how a skew works, I find all the other tools fall in line behind it. So that's a skew. So lose that. So now I'm going to reduce the diameter here of the handle, and that's to suit your own hand size. I've got pretty big hands, so I will have a fairly bit larger diameter than most people will. So at that stage, has anybody got any questions?
Somebody wants to know, Phil, if to soften the corners on their tools, like parting tools, will it protect their tool rest?
Yes, some tools come out of the factory with very sharp edges on them because they are straight off the surface grinders, and they're difficult to slide along the rest and will mark in the rests. So yeah, just with a diamond file or a slipstone or something, just run over the edges of them. I've got my favorite diamond file there that's always to hand. And if this was a standard tool, I just run it along the edges. This is double-sided. It's actually a knife sharpener, this one. You can probably hear the difference in that. So that's just, just run that along the edges, just to take those sharp corners off. Anything else?
Just the size of the timber fill that you're using, and also timber fir mallets that you recommend.
This is a piece of cherry. It was just under 4 inches, sort of 3.5 inch square. Any relatively hard wood you can use. As I say, they're good fun doing out of wet wood because they actually go oval, and then you've got a nice oval handle. I mean, in this country, mallets traditionally were made out of beech, but for just knocking around the workshop, fruit woods are good. The first one I had was out of apple wood, but you could do, you know, oak, elm, ash. There's no real hard and fast rule, I don't think, for making a mallet. It's only just for knocking around the workshop, unless you're making one as a meat tenderizer, that you would want to use ash or beech really, because they have timber has a butcher's blocks. They have an what's the word I'm looking for? The reason butcher's blocks are made out of beech is that they don't, bacteria can't grow in it. There's an antifungal, I think, in the wood itself. So yeah, but just, you know, whatever you've got. The one thing I would say, and I said earlier, was not to use a branch, because it will split if it's green. So if you can cut it so that it's away from the pith, and then you'll get a you know, nice oval mallet. But wood, you know, I can't say what you use in the States, but just anything really. I mean, poplar wouldn't be very good, but any reasonably dense hardwood.
Okay, Phil, I think this question means, would that file that you've used smooth your tool rest?
No, it's not coarse enough for that. You'd use a machinist file to do that. That's just for, I use that for sharpening my hollowing tools, and it's not coarse enough to do your tool rest. You could polish it with it, but not for removing a lot of material.
Okay, David Buskell kindly put up a link to your book there for anyone interested. Lots of suggestions there from people about different types of timber for the mallets, but I think you've answered all that anyway, so you're good to go again. Thank you. Okay.
So now I'm going to reduce, we need to take quite a lot of wood off here. So I'm just going to reduce that, and I'm just going to do this in steps. So I'm up the speed again. So I'm about halfway up the scale. So this is probably doing about 1500 RPM, I think. I set on a high ratio, which is from 30 to 3000 RPM. So I'm doing it at 1500 RPM. Nice sharp gouge. Take your time. You can get some really nice shavings coming off. Doesn't really pick up on there. The diameter I want here is around sort of 40 mil. Trying to hurry it. So it's telling me I'm trying to hurry it up. I'm being too aggressive with the tool. That's when it stops. This sort of doing this is good fun because I've got a nice pile of shavings. Let's see if I can just move that there. I've got that lovely pile of ribbons just down there by my feet. That I personally, it's fun to try and get ribbons coming off. Nice sharp tool, and getting a really good finish straight off the tool. But it's just fun, just to make shavings, and to do that, you're just progressing the tool at the same rate all the way down there, just to get those lovely ribbons. When I used to teach in Germany, I learned sort of salient phrases, and one of them was, every cut is a practice cut. I'm not going to try and say it in German, because when I do, everybody criticizes it. But it's true. It's, you know, every cut should be a practice cut, so that you're applying the same amount of pressure to the tool, so you're getting those nice even shavings coming off, and that way you're actually in control of the tool. You know, it's telling you you've got control of the tool. And with a nice fine wood like cherry, you get some great shavings. These friction drives don't work well when you've got end-sealed wood, because end-seal is basically a wax. So these friction drives don't work in that case. So here, where I've got the coming up against the head here, I'm being a little bit careful about how I approach that. I'm not going to come in on this wing, because you'll get a catch. Just using this face here to rub the bevel against, to try and get down in there. So I'm going to reduce this a little bit more here. Just tighten this tail stop up again. Probably a few more revs. So I'm creating the shape in steps. So all I've got to do is just a smoothing cut to get the handle, the shape of the handle in there. Now, if you don't want to use a skew, if you're not familiar with using a skew, you could leave the head that shape, or under the head that shape, and just do that. But I prefer to put a little bit of decoration in there. So now I'm just creating a nice curve in the handle, putting a taper on it so that it just doesn't drop out of your hand, and just feels more comfortable. It's going to fit your hand better. One more cut. So I can use the wing of the gouge like I would a skew and get a really good, so that's coming off about a third of the way down that face, and just getting a really nice finish off the tool. Get that bit off there. So that's pretty much the handle done. I prefer, as I said earlier, to have a V cut in here. So I'm going to go back to the skew, which is here, and just come back up the head, and this is just 1/2 of a V cut. Just using the point to arc down there. Just nice and slowly, just clean that so you get a really nice clean face in there. So at this stage, I'll clean that up in there. So I'm just going to put a little bit of a curve on there. So it's just rolling the tool over. Now you don't want to go too small in there, because if you go too small a diameter in there, it's going to be too fragile, or not very strong. So about just over 1 inch. That's what I prescribe anyway. I can with the gouge, make that a little bit shorter in there. Just take that out there. When you do this, just check. I'm not sure why I'm getting a bit of vibration there, but I am. Just check that it feels right. Yeah. You see I've got pretty big hands, but that fits pretty much perfectly there. So now I'm going to put a taper on the head. Now, why do you put a taper on the head? If it's parallel, it just doesn't feel right when you're hitting something. And if you look at, say, an upholsterer's mallet, the ends, they're a block head, but the ends are always slightly tapered. So it's just put a bit of a taper on here. I can use either the roughing gouge or the skew, but I get my students to use a skew. What I've done is just angled the tool rest at the angle I want of the taper that I want on the head. So I'm going to work from left to right, rub the heel, just with the cut in the middle of the tool. I'm looking at the horizon, getting some really nice ribbons coming off here. You'll always get a really good finish with a skew. We're not doing anything spectacular with this, just using it to make V-cuts and planing cuts. But because I've got the tool rest at the angle that I want to have on the head, I'm not really having to do a lot with the tool. And it's just really satisfying to get a mountain of ribbons like that. And that could probably be one shaving all the way down there. One ribbon. Okay, so I've got that little bit of a curve there, so it's a little bit more off down there. Now I have no idea why I'm getting vibration on this. I don't think it's the skew because it was happening in here as well. Perhaps too much tension on the tailstock. So that's pretty much the shape we want. But what I want to do is put a little bit of decoration on it. So it's got, nice taper there. Feels good in here. So what I'm going to do is where I've put a curve in here, I'm going to do the same this end with the skew. And just nick that corner off first. And as I do the next cut, I'm just going to ease the tool around a little bit. Let's go to tailstock. Let's see if that's... Is that a better view, Pat?
Yep, sorry, that's good for that, Phil.
So just putting a little bit of a dome on here. And again, it's a good little exercise in tool control. Take your time, just bring the handle round and do a few little V cuts down there. We're not going to go anywhere near parting off yet, so I've still got ½ an inch of timber there. While I'm here, I'm just going to put a couple of little V cuts in there, just as a bit of decoration, and use a hot wire. Always do 2, never 3. 2 you can always get the same distance apart. But if you put 3 lines, you're going to really struggle to get them equidistant. So that feels good, and it's, you know, it's not going to, the taper on here, it's not going to fly out your hand. So to put some decoration on there, it's just a wire. This is actually a strand of a bicycle brake cable. So we're there, we're good there. So all I'm going to do is just locate it in the groove and just wrap it round. I'm not pulling very tight. That works. And just gives you a little bit of decoration. You can, if you want to get fancy, do a bit more decoration on there and this is a technique shown to me by the hat man, Johannes Mikkelsen, whatever you want to pronounce his name. And these are thin strips of veneers. In this case, this piece is a bit of rosewood. I'm not sure which one, but it's a rosewood. And what I'm doing is sharpening the ends on a bit of 80 grit abranet to a knife edge. Now, if you want to make some filler, you can do that. Gather the dust up, and you can mix it with your Aerodite or super glue or whatever to make fillers. I don't, but you can. This is a piece of bloodwood. So you can see this is very red. And then finally, piece of ebony. And they're just sort of 2 mil thick, or what's the equivalent of 2 mil thick in Imperial? 3/16. Nod your head, Kate, if that's right. 3/16. No, it's not. I can just see.
Yeah, that's right.
Yeah. Thank you. So that's a nice knife edge. So I can get the tool rest up nice and close in there. And what I'll do is start with the bloodwood. So I want fairly high RPM on this now. And as you push it against it, it burns in color. So that was the bloodwood. This is rosewood. So you can really personalize your...
Anybody home?
And then to differentiate them, use the, or differentiate, put delineate. Just use the ebony to create a really black line. Just a bit of fun. Something a little bit different. You don't necessarily need to do both. The hot wire and that, but that's pretty cool. It kind of looks like an est wing leather handle, and gives it, yeah, really personalizes it. I don't sand these. I don't personally. I don't sand them because I'm only going to use them knocking around in the workshop. I can see about 6 here. There's 3 behind me. There's 2 over there and another one over there. Every time I do a course, I make one to show the students. And sometimes they want to sand and polish them and take them home. If you wanted to, and then use a hard wax oil finish, so that if they are dented, the finish isn't going to come off. I don't put a hard finish on them like a lacquer or waxes or stuff like that, just a coat of a hard wax oil. If you wanted to make it into a meat tenderizer, you could put a series of V cuts in here to beat your stakes with. So that's Dave Buskell. That's one of the projects in my book, and I used boxwood then. Okay, what I'm going to do now? How are we doing for time, Pat?
That's down to you, Phil, as long as it takes.
How long have I been going? Nearly an hour.
It's now, you're about the hour mark near enough.
Yeah, yeah.
Couple of things, Phil. People are just asking about the wire that you would suggest to use for burning, and you can cover all this into one. The obvious one about safety regarding using things like that at the lathe, and types of wire. People recommending guitar strings and things. I think you can cover all this.
Okay, the reason I use bicycle brake cable is that many years ago I used to be in the bike trade and have still got some brake cables hanging around, and I just unspiraled one strand off it. Talked to somebody the other day, and they use wire from copper wire out of your electrical cables. What they hardwire the house with, not the flexible stuff, what they hardwire the house with, that works well. It's a fair bit thicker. I quite like to have a fairly fine line, but yeah, it needs to be of a thickness that will heat up fairly readily. I think, you know, something like fencing wire would be a little bit too thick and take too long to heat up and wouldn't really work. But yeah, I'm not good with gauges, but the bike brake cable is pretty thin, and the electrical wire is a bit thicker, so it's going to give you a thicker band. As to the safety of it, I'm not actually wrapping my hand around it. I'm just pulling it round. Let's go back to the overhead. I'm just, as I said, I'm just wrapping that round. Let's go tailstock shot so you can see how much it's the length of all the wire between the handles is engaged in the wood or touching the wood, and that's what's causing the friction. Not putting a huge amount of pressure on. It's just wrapping it around it. This piece has got, you know, shorter and shorter, and I'm going to have to take another piece off that bike brake cable to do it. Does that cover that, Pat?
Yeah, that's it, Phil. I think the rest of the safety involving glasses or shields is kind of a given anyway. So
yeah. I mean, I explain why I'm not wearing one, because if I keep touching that with my face shield, it's going to get, you know, people are going to be seasick. Okay, at this stage, I'm pretty much done. What I do though is just nick this corner off, this top corner, just one cut there, or two, just to clean that edge up. Can do the same down here if you want. This is where you can, you know, really personalize them. Now, coming to parting it off, I'm going to use the point of the skew to get this as clean as I can. I'm just peeling that away down there. I'm going to go down to about 1/8 in here. And where I said earlier that these ends match, because I will struggle to get down here, this end, I'm going to reverse it, so it's a lot easier to do. Because one of the reasons, or what I do with these, is make a concave head, so that's slightly concave, so that it stands on its end, rather than takes up less space on the bench, but also, you know, you drop it on the tilt, they'll roll around. So if you've got a nice little concave head there, they'll just stand up. So because these match perfectly, they are exactly the same profile. That's running perfectly true. So now I'm just going to move that camera again. Excuse me for a second. there so you can see what I'm doing. I might go for a zoom. There we go. So get down in here. And now I'm going to gradually come up this face, 2 or 3 cuts. Again, that's good where these friction drives, so these friction drives are good. If a student has a catch here, it's just going to stop. So last cut. Down there, and I haven't taken a huge amount out, but you should be able to see there's a nice gap in there. Let me get something a bit strong. Let me get a rule so you can see a bit better. So there's a gap in there. So I've got a concave head, and now it's just a case of reducing this again. I'm not going to go right through, just go down fairly small, and I could do a little bit the other end, take a little bit more off. Get that the end as clean as possible. So now take it out. Now you could just mash that. Yeah, let's just go. Sorry, I forgot to move that back again, didn't I? Too much to think about. What you could do is just mash that down on the tool rest, the lathe bed, just to crush those fibers there. But I haven't got very much, so I can either just slice it off with a, I've got a flush cut saw here, Veritas, not specifically just doing this, but something I've had for years, which is great for this little job. So it's just taking that off there. And now I can clean it up with a little carving tool and just pare that away. Use my thumb as a fulcrum, so these fingers are nowhere near the cutting edge. And the same the other end. Just arcing the tool into the cut. Cool. One personalized mallet. So that's, yeah, done.
Well done, Phil.
Anybody got any questions?
You've covered most of the questions. Lots of comments about their shorts, safety, that you're not wearing jewelry and things. People are complimenting you on that. You have people in from all over the world, as I said to you, South Africa, Australia, everywhere.
Wow.
So, yeah, you've topped our bill at 116 viewers. So lots
80, I can see there's 81 comments in the chat.
Yep. Most of them are bad. I didn't read those ones.
Okay.
No, lots of compliments, Phil. Well done. So if people